Hello and welcome back to your channel of Math and Engineering Made Easy. Today, I'm going to visit the Mohr Circle again. In fact, we'll have like 3 sessions. This is the second one. But this time, I wanted to show you the combination between Mohr Circle and linear algebra. What do I mean by that? I mean that we can use eigenvalues to find the principal axes at a point. So let's take an example, a quick example, an easy one. So let's say I have my element, looks like that. I have tension on both sides. So on the X, I have, say, 40 megapascal. On the Y, I have also tension like 30 megapascal. The numbers are not important, but the way we are presenting. And then the shear, let's say it's positive shear like that on the X. Oops. Oh my God. And it's 15 megapascal. Okay. So when we draw the Mohr circle, so that's if we were doing the last session and solving it using Mohr circle. So we'll start with that, and then we'll see how we get so we can compare the solution. I just didn't want to do it without Mohr circle, and you say, okay, so how do I know this is correct, right? So this is the sigma, and sure enough, we said this is the tau. We are going to draw it down. So we are going to locate 2 points on the circumference of Mohr circle. The X point is tension 40. So I am at 40, it's positive. In fact, both of them are positive, but it's positive 15 down. So let's say it's here. So this is 40 and 15. And on the other end of the diameter, that would be the point 30 and negative 15. Notice negative is up and positive is down. And this is 2 theta. So we can find this point. Notice this point is the average between the two. It's like you can use the midpoint formula. 30 plus 40 over 2 is 35. And sure enough, 15 and negative 15 would give you 0. And I want to find these 2 points as well as the angle 2 theta. And we said it's so easy to do it because I can construct a right triangle here. Right? And I say this point would be 40 and 0. So really you can see a triangle, a right triangle here, whose base is 5 from 35 to 40, and its height is 15 from 0 to 15. So this would be what? 5 square root of 10, the radius. So the radius, which is tau max, is 5 square root of 10 megapascal, because this is 5. If you divide by 5, you get 1, 3 root 10, right? Square root of 1 square plus 3 square is square root of 10. So of course you can use a calculator and find this value. Oh my God, did I? Let's see. No, we need it. Unless I use, yeah, I can use the small one, or I can use my phone. I have, it's very strange. I just had it. Okay, it doesn't matter. Here is my phone. So we can say 5 square root of 10. Oh, there is a negative. And what is that? 5 square root of 10 equals 15.81. So we say sigma 1 is 35 plus that, so it's 50.81 megapascal. And sigma 2 is this minus that, so it's 1919, right? Megapascal. And then we can find 2 theta. So 2 theta is arctan 3, right? 15 over 5. So theta equals 1/2 arctan of 3.5 inverse tan 3. 35,782. But this angle would be twice as much, of course. That would be 71,565 degrees. Okay, so that's quickly how we did it last time. Or I didn't do this example, but how we solved Mohr circle. Now, let's see if we have a matrix where we have sigma 1 and sigma 2, the 40 and the 30 on the main diagonal, and then you can say 15 or negative 15, it doesn't matter, as you will see. So I can write 15 and 15 or negative 15 and negative 15, it doesn't matter. Now, again, I prefer, I don't know how to show you that, but okay, usually we say lambda minus 40. It's basically 40 minus lambda, right? And then negative 15, and then negative 15, and then 30 minus lambda. But if I multiply, notice that I will take this determinant and equate it to 0. So if I multiply by -1, it becomes easier for you. I mean, it's exactly the same thing, but it's easier if you simply even write it like that. Notice that lambda minus 40 times lambda minus 30 is exactly, will give you the same value as 40 minus lambda times 30 minus lambda, but you are used to do x plus or minus a times x plus or minus b, right? It's easier. It's the same thing as a plus or minus x. And same thing here. If I use these 15, 15 or negative 15, negative 15, the product would still be 225. So really it doesn't make any difference. So now when you find the determinant here, you will get lambda square minus 70 lambda plus 1200 minus 225. And you equate that to 0, right? Just don't want to waste your time, so I'm trying to do it fast. Minus 70 lambda, and when I do it fast, sometimes I do it wrong, right? When you subtract 2, you get 975 equals 0. So lambda equals negative b, so it's 70 plus or minus square root of 70 square, which is 4,900, minus 4 times that. Notice 4 times 1,000 is 4,000. So we subtract 4 times 25, which is 100. So instead of getting 4,000, you get 3,900 over 2. So you get 70 plus or minus the square root of 1,000 over 2 equals 35. Yes, 35 plus or minus. If I take out 100, they go out as 10. And then you divide by 2, so you get 5. So plus or minus 5 root 10. Guess what? Plus 5 root 10 will give you this, minus 5 root 10 will give you that. Exactly the same. Oh, I would claim that Mohr circle is faster. Okay, but you get the same result, exactly the same result. 35 plus 5 root 10, which is this value, and 35 minus 5 root 10 is that value, because we added 5 root 10 and we subtracted 5 root 10. See how easy it is. Now, something else I can show you here. Remember when we learned about the rotation? Okay, do you remember the rotational matrix? If I want to rotate, notice I'm rotating counterclockwise. So my matrix of rotation for counterclockwise, that should be a new pen, I don't know what's wrong, is cosine theta, negative sine theta, sine theta, cosine theta. Here we have a small trick. Times the original point should give me the terminal point. Here, two things I want you to be careful about. So it's not that easy if you are not paying attention. First of all, what are the coordinates of the first point? Most people would tell you it's 40 and 15. No, it's sorry, baby, it's not. It's 5 and negative 15. What? Notice, I work assuming this is the origin. I cannot pick any point and work from it. It won't give me the correct answer. And think about what we did back then when we were doing the rotation from any point about any other point. And you would understand what I'm saying. So all what we are saying is, if I take this, think about it. If I take this circle and move it 35 units to the left until this point coincides with the origin, would that affect 2 theta? It's the same, right? So that's what I'm going to do. I'm going to assume this is the origin. So the coordinates of this point is 5. Notice I went down. I don't care about the tau being positive down, and no, now I'm using x and y as if these are the coordinates of a point in the Cartesian plane. 5 and negative 15. 5 and negative 15. That should give me not 50, 15.81 and 0. And then solve 2 equations in 2 unknowns, sine and cosine. So the first thing is you assume this is the origin. Second thing, anything below is negative. I don't care if it's a positive shear, but notice I'm rotating counterclockwise, so it has to be negative. If it were positive and you rotate counterclockwise, or you assume it's positive and rotate counterclockwise, you make that negative and that positive. I don't want to confuse you, but be careful. So I will get 5 cos theta, negative times negative is plus 15 sine theta equals 1581. And 5 sine, I'm going to write it under the sine, right? It makes more sense. Minus 15 cosine equals 0. Some people will tell me, should I solve for sine or cosine? I don't care. No, I do. Why do I do? Why do I do? Because suppose this point was here and I didn't notice and I wrote it 40 negative 15 instead of positive 15, meaning I assumed it's here while it's there. If you solve for cosine, cosine wants to tell you we are rotating clockwise. But really, the cosine of 2 theta, if it's under the x or above the x, both of them are positive because the cosine is positive in the first and fourth. So really, it won't show you that you did some error. Meaning, if I erroneously wrote this as negative 15, I'm sorry, as positive 15 or negative 15, I wouldn't know, should I rotate clockwise or counterclockwise? Because theta and theta, in whether it's in the first, as I said, first quadrant or fourth quadrant, both of them are positive. So I want to stay away from that. I will always solve for sine because the sine here is positive, meaning I'm doing like that, or negative. It will tell me turn negative if it's negative. So I want to get rid of the cosine. I'm going to multiply this equation by 3. And then add it to that equation. So I will get 15 cosine plus negative 15 cosine, they cancel each other. 3 times 15 is 45, plus 5 is 50 sine theta equals 3 times that, which is with 47.2023 or something. We can do it with a calculator. So theta, in fact, this is 2 theta, not theta, right? Because we are solving for Mohr circle. So I hope I'm not confusing you. We have 2 theta on the figure. So I'm going to say multiply, let's first get, let's get 35 plus, no, I don't want 35. I don't want the 35. I want to get 5 root 10, right? 5 square root of 10. This is this number, which is 1581. Oops, it does, okay. Okay, 1581. I'm going to multiply it by 3 and then divide it by 50. So I'm going to take inverse sine of 3 times that over 50. That should give me twice theta if I did my math correctly. I hope I did. Yep, 71,565. Exactly the same thing. So here, even, of course, I had to draw Mohr circle, but I didn't use Mohr circle like geometry or the equations that give you sigma 1 and sigma 2 based on sigma x, sigma y, and tau xy. Very easy equation. Everybody have it. But I used instead the eigenvalues. They give me sigma 1 and sigma 2. And then using rotation of a point to give me the angle that we rotated about. I hope you like that. Again, it may or may not help you. Most likely, I would rather use the Mohr circle. It's easier. I know how to calculate the diameter, the radius easy. And then add it and subtracting to get sigma 1 and sigma 2 and use arc sine or arc tan or anything to find 2 theta. However, again, it's a good practice of eigenvalues, how to find them, and you can also find eigenvectors and do the multiplication, like eigenvectors times eigenvalues times the inverse of eigenvectors, and see if you get the original matrix again, just to make some, you get used to linear algebra. We may have some sessions on linear algebra later, but for now, I hope that was an easy and light session. Again, as usual, if you have any questions, please don't hesitate to email me. I will have another session talking about 3D stresses, because we said these stresses are in 2D. So what if we want to find, or when the 3D becomes an issue, okay, so to speak. Alrighty, thank you very much. And again, wish you all the best. And until I see you again, have a nice time.